Okay. All right. So for our simulations, okay, we're gonna do this with basic steps, and we're gonna use this song to learn the basic steps. So you have got this extra thing here, and we're going to begin with just the problem that you have on page 17 in your packet. So get that out, page 17 in your packet. All right, so here's a problem. I wish to select a simple random sample of 4 students from this class of 30 to participate in a survey. So indicate how I could use a random number table to do this and include a careful description of how the digits will be assigned and how the selection process will occur. Use the accompanying random number table to demonstrate how you would make this selection. Mark on or above the digits in such a way someone reading your paper could follow your work. Okay, so this will happen on the AP test. They will not ask you to do this problem with a random number table, random number generator, like I've had you do in your calculator or on your phone before, random number generator. They will give you a table of numbers like this here, and they give these numbers to you in sets of 5 just for the ease of reading. So they have them in groups of 5, and you can still, if you're doing numbers, you can bridge, across the gap to get a number value if you need to. They are only in groups of 5 for the ease on your eyes. Okay, but let's talk about the first step that we need to do. Our little song page here says each digit represents. So you have to define up front what the number digits are going to represent in your problem. And you're going to either have 1 digit, 2 digit, 3 digits, or so on. And this is based on the problem itself. So let's take a look at this. If we are dealing with up to 30 students, then what kind of digits do I need to have? 1 digit, 2 digit, 3 digit, what? 2 digits. Very good. Why is it going to have to be 2-digit numbers? Yes, since I'm going up to 30, I'll have, 10, 11, 12. I'll have 2-digit numbers in there. Okay, so that's why I have to have 2-digit numbers. All right. Furthermore, you cannot run a simulation and switch between 1-digit and 2-digit numbers. For example, if I was to look at a set of numbers, when I start looking at this first set of numbers, is the first number 8 or is it 84? Okay, is this one 1 or is it 17? All right, so you have to define how many digit numbers you're going to have, and you always have that in this problem. So do you see this 0, 5? That is how the number 5 would be represented, is if you had a 0, 1, 0, 2, 0, 3, so that it is represented, see here's a 0, 6, by a 2-digit placement. All right, so here is how we write that. Each 2-digit number represents a student from this class. All right, so fill that in. Each 2-digit number represents a student from this class. All right, so for our song, it's each digit represents, let the numbers be. Okay, each digit represents, let the numbers be. Okay, so let me explain to you what I mean by let the numbers be. You're going to define which numbers are available to you. And for these, I want to go from 01 to 30. So let the numbers 01 to 30 be assigned to a unique student. You could say assign this in an alphabetical order, so something along those lines. It also might make sense at this time to say which ones to ignore if you're, leaving some of them out. So I'm obviously leaving out which values. So I'm ignoring 31 to 99, and then there's also one more, the 100th two-digit value, which I will represent as 00. So I'm going to ignore numbers 31 to 99 and 00 because I'm only going to look for the numbers 01 to 30. All right, so here we go. Each digit represents, let the numbers be. Use a random number table. Start here, please. Okay, so what that means is you have to tell the reader, because the reader has to be able to follow you exactly, what they're going to use and where they're going to start so that they can reproduce the same results. So use the random number table below and start at the top left corner. You know, it matters. While you're writing that, I'm going to tell you, it matters that you're telling me where to start, because in other cultures, I know in another part of the world, they write from right to left. So it could be that if someone from that part of the world is doing research, then they're doing a number table from right to left. Okay, so you have to tell them how you achieved the results that you did. All right. So, and I'm going to keep singing this, not because I like singing at you, but I think as I do it more and more, it kind of helps you memorize it as we go through. So, each digit represents, let the numbers be. Use a random number table. Start here, please. All right. A trial consists of stop and ignore. Okay, so that's the next thing to tell you. You have to tell me what a trial is going to consist of, when you stop that trial, how many you go until, and I had previously already in this problem addressed ignoring numbers 31 to 99 and 00, but talk about repeats. You know, are repeats okay in this problem? So let's talk about that. Well, first of all, what is a trial? What do you start looking at? I'm going to start looking at what? Two-digit numbers. So I'm going to start picking two-digit numbers. And how long? When do I get to stop picking two-digit numbers? Right, until I get what I was supposed to get. And the question wanted me to have 4 students from this class. So a trial consists of picking two-digit numbers until 4 different students have been chosen. And I'm ignoring numbers 31 to 99 and 00. And I am ignoring repeats, because suppose I pick number 11, and then a little bit later when I'm still picking people, I pick 11 again. Can I have a person picked twice? Can I have a person picked twice and achieve 4 different students? No. So this matters. Do not have repeats. All right. Each digit represents, let the numbers be. Use a random number table. Start here, please. A trial consists of stop and ignore. Your response is critical. What will you look for? This is probably the most important phrase in this whole thing. Actually, it seems, each year I kind of organize this stuff even better, and this is the first year that I really was like, you know what? There are 3 different kinds of problems. And so let me just up front explain to you the 3 different responses that you can get. Okay, so I want you to write these down. The first kind of response is just picking items. That's what we're doing in this problem. Your response is the numbers that are the numbers of the students that are to be chosen. Okay? And the second problem we're going to do today is going to be a problem where you say, look at 5 people and you say, yes, no. Did you get 2 boys and 3 girls? Did you get exactly what you wanted? Yes, no. Answer. That's the type of response in that type of problem. The third type of problem is the number of items it took to get what you want. The number of items it took to get what you want. In this case, it would be something like this. Pick out M&Ms until you get a red one. Okay, on average, how many do you think that you're going to have to pick to get a red M&M? Okay, so those are the three different kinds of simulations that we will be performing. All right, so let's continue with this first one, the items chosen. So here, our response that we are measuring is the students that get chosen. Okay, and so let's then go ahead. The next thing is, get your statistic, man, because I want to know. Well, that's when you're going to run the simulation. So let's run this simulation, okay? Here we go. You got this number table. I'm going to start picking two-digit numbers. Here we go. So you write actually on the number table in the AP test and wherever it is that you're showing them how you accomplish this. So there's a two-digit number, 13. Is that a student that gets chosen? Yes. So I'm going to put a check mark to indicate student number 13 gets chosen. The next is the number 96. What do you have to say about that? That is not one that is a valid number for the class. So the next one is 27. I am bridging the gap over that blank. And is that a student chosen? Yes. How about 09? That is also another student chosen. 92? No. 65? No. 17? Yes. And now I'm done. Now you may wonder, why is there so many numbers? Well, there's so many numbers because you may have chosen a different way to represent the students, and it could have taken a lot longer to find 4 students, okay? Or maybe they would have asked, what order would the students be chosen in, and so you have to go through all 30 of them. All right, so the statistic is the students that got chosen. Find your statistic, man, because I want to know. Statistic is the students that I chose, numbers 13, 27, 9, and 17. And this is a little redundant on this type of simulation. The summary statement is, according to my simulation, about what does this show? I mean, well, you just kind of are repeating the same thing. It's kind of, again, redundant on this type of simulation. So according to my simulation, I will pick students 13, 27, 9, and 17. And that's the end of that one. That's right. This is a table that came off the internet that I Googled random number tables, and then I just copied and pasted it in there, okay? So somebody sit there and used a random number generator and put all those digits down, okay? All right, so that's that. If we look over here at the little song, your response is critical. What will you look for? Okay, we just did this kind, the items chosen, and that response was just a list of numbers. Okay, so our end answer there was a list of numbers. And get your statistic, because I want to know. That's where you actually go to the number table and mark on it and run the simulation and get your answer. And then according to your simulation, about what does this show? So you approximate what it is. Well, in this case, it's just a list of numbers. All right, let's do another one, but I want to do this type B. I want to do this kind where it's asking you, yes, no, did you get what you were trying to achieve? And so I want to show you what that looks like. All right, so it's number 2 on your notes. Down here at the bottom, about what is the probability for finding 2 heads and 2 tails if you toss 4 coins, complete 20 trials to estimate the probability. Okay, So, let's see. Okay, each digit represents. Okay, what is each digit? Oh, are we going to do one-digit numbers, two-digit numbers, three-digit numbers? What you want to do? Five-digit numbers? Fine, go ahead. But that's going to be way too much work because you would have to assign half of those numbers to heads and half of those those 1,000 or 9,009, yeah, 10,000 numbers to, yeah, the odds and evens. Okay, I still think that would be a little much, but let's try a little simpler. How else could I easily account for half numbers being heads, half numbers being tails? Yes, I'm going with one-digit numbers. Okay, I can easily do half heads, half tails on that. Now, you got options, and people could come up with different numbers in the end, but they'll be about the same amount. And it would be different because of sampling variability. If you decided that you wanted the numbers 1 to 5 to be heads, and then 6 through 9 and 0, because 6, 7, 8, 9 is 4, 0 makes the fifth, to be the tails, then okay, you can do that. No, 0 to 4, you'd have to go 0 to 4, 5 to 9. Okay, you can do that. I've had also people say number 1 is heads, number 2 is tails, and ignore the rest. Okay, and that would be a good way to show you. You might have to go through a lot more numbers, okay, because it would take longer to find enough number 1s and 2s or to run 20 trials. Okay, ignore the rest. I chose odds and evens, so let's go with that. So each each one-digit number represents a side of the coin. Each digit represents, and then the next thing, let the numbers be. So what am I going to let be what? Let the evens, by the way, 0 is neither odd nor even. So let the evens and 0 equal heads. So that 2, 4, 6, 8, 0 are heads. 1, 3, 5, 7, and 9 are tails. Each digit represents. Let the numbers be. What's next? Use a random number table. Start here, please. So, I think it's on the top of the next page. Use a random number table. I've said below, but I mean at the top of the next page, and start at the top left corner. Use a random number table. Start here, please. All right. What comes after that? A trial consists of stop and ignore. Okay, so let's think. What's one trial? Okay, 20 is not a trial. I will complete 20 trials, but what is a trial? 4 coins or 4 numbers, because you are tossing 4 coins. So look at 4 one-digit numbers, or in this case, a trial consists of tossing 4 coins. You could say looking at one-digit numbers. How about repeats? Are repeats okay? Yeah, because if you had, say, 2, 2, 2, 2, then, okay, that just means that you got 4 heads on that. So repeats are okay. I think it was a little redundant or unnecessary to say all one-digit numbers are okay, but anyway. So a trial consists of tossing 4 coins, but when do you stop? Stop and ignore. We don't have to ignore repeats. When do you stop, though? Good. Stop when 20 trials have been completed. Okay, so each digit represents. Let the numbers be. Use a random number table. Start here, please. A trial consists of stop and ignore. What's next? Your response is critical. What will you look for? What are we looking for in each one of those trials? Perfect. If there is exactly 2 heads or 2 tails, so what is my response to looking at that trial? Yes or no? I say, yes, I had exactly 2 heads and 2 tails, or no, I did not. So, response variable, yes, no, that a trial has exactly 2 heads and 2 tails. All right, so now, let's see. Your response is critical. What will you look for? Get your statistic, man, because I want to know. That is, go run the simulation. So go to the top of the next page and let's do that. You have this number set here. I am going to first mark off 20 trials. So I'm going to first draw a vertical line every 4 digits until I have 20 trials. I gotta mess up somewhere. Okay, and then after we do that, we're going to be looking and seeing, what are we going to check for? 2 heads, 2 tails, meaning, are there 2 odds and 2 evens in every single one of these sets? And I put a check or an X. Okay? Okay, and then I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's the end, and so the rest of these numbers I don't use. Okay, so there's my 20, and how many of them had 2 odds and 2 evens? 7 out of the 20 had 2 odds, 2 evens. That's your statistic, man. Okay, so you will get a percentage for this response with this statistic. See here? When you have a yes, no, did you get what you wanted? You'll end up with the percentage of time that you got what you wanted as your statistic. So you will finish here. The first one we did, we finished with a list of numbers of the students chosen. This time, we got a number that told us the percentage of time that we get exactly what we want. All right, so we say this, that 7 out of 20, which is 35% of the time. So according to my simulation, I expect to get exactly 2 heads and 2 tails on 4 coin tosses about 35% of the time. Every time I do this, am I going to get 35% of the time? No. Why not? Yeah, next time I'm going to have different random numbers. Now, will it be approximately 35%? Yes, it will be somewhere in that ballpark. I don't know the standard deviation, but anyway, somewhere around there. I could actually figure it out, but okay. Okay, so each digit represents, let the numbers be. Use a random number table. Start here, please. A trial consists of stop and ignore. Your response is critical. What will you look for? Get your statistic, man, because I want to know, according to my simulation, about what does this show. Okay, so there's that. Let's do one last problem, which is the third type of simulation. Um, it actually is not on these notes because I kind of just got that all straight in my brain this year, that about this morning, that there's just like exactly 3 kinds. So I want you to turn to page 21 in your packet, because that's where you're going to find the third type of simulation that I want to practice. So turn to page 21 in your packet. That looks like this. All right. We actually are not doing problem 1, but we have to read it because problem 2 uses the same information. So let's read number 1. Here we go. Hey, do you know when you were little and you used to, did they have prizes in the cereal box, like different toys or something you could get out of the cereals? They don't do that anymore, do they? Have you seen that? What? There's like Cheerios right now. Oh. Oh, there is. Oh. Oh yeah, see, and Jackson's the same age, so yeah, you see that because he's all in Skylanders. Interesting. But he wouldn't eat Cheerios, so that'd be, yeah. Hey, just FYI, did you know that you can go to McDonald's and you don't have to buy a Happy Meal to get the Happy Meal toy? Yeah.
Wait, you still expire?
You can say, I want to buy Happy Meal toy, and you don't have to buy the Happy Meal. Yeah, this is going to save you a lot of money someday. Okay, we got to have this little discussion here, so hold on a second.
Do you like... Oh.
No, it's okay, what?
Did you like punish him? Did you like...
Oh, yeah, he doesn't have his iPad.
Oh.
Okay. Yeah. Okay, and all the hero toys, okay, right? Okay. From the Happy Meals. All right. Here we go. Back to the cereal. Okay. Okay. So cereal boxes with toys, but this case is Tiger Woods card. Okay, so this is going to date it. I need to put new like people on this. 20% of these cereal boxes contain a picture of Tiger Woods. 30% have Lance Armstrong. And the rest, so the 50% remaining have Serena Williams. Okay. Now, look at this problem. It says, suppose you buy 5 boxes of cereal. Estimate the probability you will end up with a complete set. So, what is in this problem, what does a trial consist of?
5 boxes.
Boom, buy 5 boxes. Boom, buy another 5 boxes. That's the trial, 5 boxes. And what's the response to this problem?
Yes.
Or yes or no to whether you got a complete set of cards or not. Okay. All right, but we're not doing this number 1, but I still had to like introduce this to you because it continues into number 2. So let's go to number 2. Suppose you really want a Tiger Woods card or a Tiger Woods picture, and you don't just print it off the internet. How many boxes of cereal do you need to buy to be pretty sure of getting at least one Tiger Woods card? Your simulation should use at least 20 runs. Okay, so let's start this thing out. Ready? Each digit represents. So what kind of digits should we have? 1 digit, 2 digit, what, and how do you know? 1 digit, 2 digit, what? Okay, so if you do 2 digit, is that because you're going to go like 1 to 20 is, 01 to 20 is Tiger Woods, 21 to 50 is Lance, and, oh, we could just do 1 digit. Since these are in tens, you could say 1 digit numbers and let 1 and 2, and just pick 2 of them. So I'm going to pick number 1 and 2. How about this? Number 1 and 2 to be Tiger Woods. 3, 4, 5 to be Lance Armstrong, because that would be the 30%. 3 numbers that I'm choosing for Lance Armstrong. And the rest, 6 through 9 and 0, are Serena Williams. Now, technically on this problem, since you just want Tiger Woods, you could technically say, let 1 and 2 be Tiger Woods and the rest are not Tiger Woods. Okay? But what was the question? Why are we what? Why did I choose 1 and 2 to be Tiger Woods? Nobody has a question? But why did I choose 1 and 2 to be Tiger Woods?
Because 20%.
Good. Could you have picked some other numbers? As long as it was 2 other numbers to be Tiger Woods, that would have been fine. All right. Each digit represents a prize. Let the numbers be, what's the next one? Use a random number table. Start here, please. Okay. So we're going to use the second random number table on the back and start at the top left corner.
Are you gonna send this video out to them?
Yes?
Don't listen to it.
Do you want to listen to that part where I don't think it's okay?
No, I just missed the first one.
Oh, okay. All right. All right, so each digit represents, let the numbers be. Use a random number table. Start here, please. A trial consists of what?
5 boxes of cereal.
Ah, on this one, it is different than problem number 1. Problem number 1 said pick 5 boxes. This one does not say pick 5 boxes. Number 2 says, yep, how many boxes do you need to get at least 1 Tiger Woods? So what does a trial do? You pick boxes until you get Tiger Woods. That's the key. So here we go. A trial consists of picking 1-digit numbers and go until I get a number 1 and or a number 2. The trial consists of picking 1-digit numbers until I get a number 1 or a number 2. How about repeats? What if I had like 5, 5, 5, 5, 7, 7, 3, 3, 2? It's okay. That just means you're having Serena, or actually Lance, whatever. Okay? All right, so repeats are okay. Complete 20 trials. Okay. Let's see here. Because it said your simulation should use at least 20 runs in the problem. The other ones, I think it said do 20. I think it's always said do 20. Okay. Let's see. Where are we? Oh, so the next one, what comes after a trial consists of what? Stop and ignore. Your response is critical. What will you look for? So this is the third kind of response. What is the third kind of simulation response that we do?
I'm pretty sure that Tiger Woods and Lance Armstrong are not on these boxes anymore.
Probably. That is so probably. I know. I need to change these. I need to change those quote-unquote heroes. Okay, I don't know. Okay. But yes, the response that I'm measuring is the number of cereal boxes it took to get a Tiger Woods card. So the response is the number of cereal boxes it takes to get a number 1 or a number 2. All right, so now get your statistic, man, because I want to know. So let's go run the simulation. So let me let you finish writing that, and then we're going to go over to the back of this page, and let's do the simulation. At the end, yep. Okay, so the repeat thing was the question. The repeat thing is like, for example, here, I go, not Tiger Woods, Tiger Woods, so I stop, and that took me 3 boxes, but now here comes the repeat situation. Is it okay to have a 7 and then another 7? That's just saying Serena Williams in that box and Serena Williams in that box. So that's not going to be wrong. The time we did not do repeats was when we were picking students and I needed to have 4 separate winners. So if I picked number 7 as a winner, then that person already won. I don't want him to win again. So 7's out. I ignore the rest of the 7s. Okay? All right, so I want you guys to go through here and go until you get the winner and then count how many that is. So that one took 8 boxes of cereal to look at to get the Tiger Woods. Okay, I want you to do this right now. Okay, and then I would have to count at that time. That does end up being 20 trials. It took you to the end of the second line. That was 20 separate trials. Just happened to be that long. What are you going to do with all of those numbers? What are you going to do with this 3 and this 8 and 3 and 2 and 4 and so on? You're going to average them, and I'm going to tell you that the average is 4.9. So I did that for you already. If you added all of those numbers up and divided by 20, 4.9. So here we go on our answers down here. All right. So what's our statistic, man? Because I want to know. 4.9. That's the average of those 20 trials. So according to my simulation, about what does this show? According to my simulation, I expect to have to buy about 4.9 boxes of cereal on average. You have to say that word on average. That's why you're allowed to write the number 4.9, because can you buy 4.9 boxes? No, that's the average, and then you can leave it 4.9 to get a Tiger Woods card. Okay, which as an aside, for those who want to review back to probability, this is going until you get something. That is a geometric type of probability. For those of you who are wanting to be good on the AP, let's start reviewing. That's a geometric probability. So the expected for geometric is 1 over the probability, and that would be 1 over the 20% chance of getting Tiger Woods, which is 5. And look at there, we hit really close to that 5. We had on average 4.9, so that's cool. All right, but that is your 3 types. So one last thing to finish this up, let's look at the responses here on our song. The first type we did was a list of items. The second type we did was a yes/no answer, and we got the percent of time that we got yes. The third kind is how many number items do you have to look at to get what you want, and that average number that you have to look at. So this is the result that your statistic will look like. Okay, that is it. That is simulations, all of the details that you have to include. Your homework is shortened from your calendar, so listen up. Your homework is only page 19, and then 20 has the random numbers on it. So that makes it just 3 simulations to do. Page 19 only for assignment. This is done. This is the end of the learning for this year. I know, it's so exciting.